Hello, everyone. Can you hear us? Can you put some comments on chat so we will know if you can hear us well? Okay, so good to know that. So hello and welcome to the Predictive Maintenance with Machine Learning Algorithm webinar organized by Boldare. My name is Mateusz Kościelak and I'm marketing lead at Boldare Machine Learning, and I will have a pleasure of hosting this webinar today for you. And before we start, just a couple words about us, the webinar, and our speakers. Boldare is a software design and development company with a strong focus on machine learning solutions. Today's speakers include our in-house experts, Boldare's machine learning engineers, like Tomasz Bąk and Paweł Krynicki. Tomasz has a PhD in statistics and has been working as a data scientist for the past 7 years. In the past few years, he has been developing machine learning algorithms for major commercial banks and online travel booking platforms. In summer, he joined the Boldare team. And Paweł is a senior software developer with a backend background and 8 years of commercial experience. For the past 2 years, he has been exploring machine learning algorithms and has formed the machine learning team at Boldare. And our last speaker is our product designer, Paweł Capaja, which has over 10 years of experience designing software interfaces for clients worldwide. While a machine learning algorithms work in the background, Paweł translates the technology into quickly understandable and navigable solutions. So welcome everyone, and thank you for joining us today. So today's agenda will be posted on chat soon. We will start with the introduction about machine learning at Boldare by Paweł Krynicki. Then we will go to the interview with the whole team. It will be hosted by me. And for the last 15 minutes or 20, we will have a Q&A session, so you can just put your questions in the questions tab, and we will choose as much as we will be able and to answer it. So just one more thing before we kick off. Dear viewers, we encourage you to post your questions during the presentation, and our speakers will answer them during the last 15 minutes of the webinar. So just as I said, put it into the questions tab instead of chat tab. And we can also encourage you, we want also encourage you to post live on Twitter, and you can use our mention, boldare.com, so we will be able to retweet your content. So I would like to ask our first speaker, Paweł Krynicki, and we can start with telling something more about how it looks like machine learning at Boldare currently. So I give you the stage, Paweł, so hello.
Okay, thank you, Matt. Let's put it on the bigger screen. Okay, thank you. So the idea is that I will first start with introducing Boldare, who we are and what we do, and then I will quickly go through some of the projects we have been working on. So Boldare is a software design and development company which emerged from combining the power of experience of Exolf, a software house, and Chillit, a web design agency. Boldare's purpose is to help its clients build future-proof, significant, and secure software that's centered around users' needs and fulfill clients' business goals. We have over 14 years of experience, during which we released over 250 software products for clients worldwide, using the skills of the over 130 people strong team we employ. We are working for many clients from various industries and regions of the world, from carpooling to renewable energy, from the US, as you can see, to Australia. You can see some of them listed here. You can also check out our website to find even more examples of our clients and their case studies. How did we help them to create useful software products for their unique business needs? Okay, now more to the topic. So we believe that AI is the future, and we try to make it happen. So, there are already some solutions on the market based on the machine learning models, but the number is relatively low, and there are many everyday problems that can be quickly and permanently solved by implementing ML models. and utilizing them as a software. So not only to build models, but also to use them and implement them as a working solution. And usually in business, a problem is cost. So in other words, we can save our clients money. And we are also working on solving various problems by implementing machine learning-based solutions. So let's have a look at some of them to give you a clue what can be done with this kind of approach. Firstly, a problem the majority of any kind of business is struggling with, so customer churn. A customer leaving your company is something which obviously should be avoided. When a customer leaves, your profit decreases. Also, an unhappy customer can also take some others with him. How to recognize that the customer might potentially think of leaving your business? We have built an algorithm and a software application which took the historical data about user actions, and by finding the pattern, the model was able to predict for each active customer the probability that he will churn in the upcoming month. Thanks to that, our client could make some actions like giving some extra discount or to just retain the customer. So maybe let's go to another kind of problem, moderation. One of our current long-term clients has faced an ongoing issue of moderation of new products. The new products were added to the system by wholesalers, and an administrator had to moderate them manually. The process was painstaking and time-consuming, and the verification of the product cannot be programmed as a classic validator. So we decided to implement a machine learning model and create a prediction mechanism which could express in percentage terms the probability of data correctness of an unverified product. Next example of a problem which might be solved by ML models is something widely used in all kinds of multimedia-related software and e-commerce, for instance. It's recommendation systems. This year, we organized a hackathon to build the best software product based on a predictive algorithm, which would recommend the movies the users should watch. Multiple cross-functional teams created from our software developers and designers spent one day on building different solutions, and the winner created a chatbot which integrates with Slack. They name it Hitch, and since then he joined our company's Slack workspace, and at any time our teammates can chat with him about movies. Now something related to image recognition, validating faces. Almost every software which allows users to register and log in support also profile pictures. One of our clients had this business requirement that the system should ensure there is a proper face in the picture and it's not covered by any sunglasses or hats or something like that. So we have built a face validator, a library which can be plugged into any Symfony PHP application. It allows to easily set up the validator, provide all the criteria, and attach the validator to any web form. That was a quick introduction of various kinds of problems we have faced and where machine learning models can be implemented to improve your businesses. Now let's talk more about the main topic of the webinar, predictive maintenance. We believe that among many others, wind industry can benefit a lot from software products based on predictive machine learning models. Predicting failures of the turbines is definitely one of the most promising areas where this kind of solution can generate significant savings in operation and maintenance. This was a quick introduction, and thank you for attention, and back to you, Matt.
Thank you, Pavel, for telling us something more about our machine learning approach and where machine learning applies in various businesses. So now let's move on the topic of predictive maintenance to more specify it for wind energy industry. So I have first questions for our speakers. So guys, tell us a bit more about how you got interested in the topic of predictive maintenance.
Right, we have a general experience in different implementation of machine learning solution. However, we do not limit ourselves only to software building according to the customer expectation. We are trying to find business problems which can be solved using machine learning. So that's how we try to approach to different problems. And during one of our researches, we came across the problem of predictive maintenance in the wind industry. And we've decided it's a very interesting topic, and it was just before Wind Europe trade show. So we decided that the best moment to start.
Okay, and what is the Wind Europe trade show you mentioned?
So probably that's my turn now. Wind Europe in general is an association of biggest wind industry companies being placed in Europe, but particularly we participated in Wind Europe Expo hosted in Hamburg. Which was a great place to meet all the biggest fishes from the wind turbine industry and stuff like that. Great place to exchange knowledge and some business contacts and validate the market itself and its needs according to predictive maintenance.
Okay, and what was the aim of the Hack the Wind, the hackathon?
So alongside the Wind Europe Expo, there has been a hackathon organized called Hack the Wind, which included two main challenges. Our main challenge was to create predictive algorithm which can help farm operators predict possible failures of components from the wind turbines. The limitation was that it had to be more or less predicting in 60 days window span, so 60 days before a failure of a component was quite a success. And it wasn't only about creating the algorithm, but also it was about creating a business model or a product that could be seen on the market and sold as an actual solution for the industry.
Okay, thank you for giving us some more detailed overview about the Hack the Wind. So maybe we can go with next question, also regarding Hack the Wind. And guys, can you tell us something more about what was your final score at Hack the Wind as a Boldare machine learning team?
Okay, so maybe I'll do this one. As Pavel mentioned, there were two stages of the competition. One was strictly technical to evaluate the predictive model regarding its efficiency and accuracy. And this stage included also a quick pitch of the solution we built, but the focus was put rather on numeric result and the description of the algorithms we used. And here in this stage, our solution took the second place. To give you some background, we were predicting failures of 5 wind turbines from one offshore wind farm for the year 2017. And we trained our model on the data from 2016. And the machine learning model has correctly predicted 11 malfunctions out of 12, whereas 2 failures were related to the malfunctioning gearbox. 2 to the generator bearings, 1 to the transformer, and 6 to the hydraulic group. And there was only 1 malfunction which our model didn't anticipate at all, and it was related to the generator itself. So in total, we would save over 190,000 euros on the maintenance of the wind farm. But due to the high rate of false positives, which costs related to calling a maintenance team for inspection of the turbine, our total generated savings were a bit lower. It was around 12k euros per turbine. In average, our model was correctly predicting failures of the components almost 40 days before they actually occurred. So that was the first stage. So the numeric resolve, and the second stage was related to the product we have built upon the predictive algorithm. Our team has created a working prototype of a software application supporting the entire maintenance process. From predicting failure of certain components to ordering even required parts, updating the inventory, and fixing the malfunction ultimately. So in this stage, we have made it to the top 3.
Okay, I think that's a pretty nice score in my opinion, and with all these savings and what we can predict. So what do you guys think? You can just put on chat your opinion on this score. So okay, we can move to the next question, and this one maybe Tomasz Bąk would like to answer. The question is, guys, I know that you've made an extensive research at the Wind Europe trade show and conference, and maybe you can tell me something more about the key challenges for the wind industry you've seen on the Wind Europe.
I'm afraid we can't hear you.
Now, can you hear me?
Yes.
Okay, perfectly. So one more time, thank you, Matt. Yeah, we spent several hours on a discussion with different people during Wind Europe, and I think that we can mention a few the most important challenges. First is the reducing of the cost and repair time in wind turbine. And this problem could be solved directly using predictive maintenance. And that's the task which we try to solve now. That's our recent project. Another problem of this industry is that we have different data formats in different systems. So there's lack of standardization. And it's a more basic problem because without data standardization, it's impossible to use predictive maintenance. So we have to deal with it. And another problem is the problem with the grid. So the energy transmission has to be optimized, and it can be done also with the machine learning. So there is another area of machine learning usage. And the last and the most general problem is the general need to the digitalization of the wind energy industry. And here we can mention the communication, the processes, the maintenance, the B2B and B2C solution, etc.
Okay, Tomek, and in your opinion, what's the future and in which direction is it going?
Okay, so as a machine learning engineer, I should answer, give me some data, and then I can make the prediction for the future. So it's more about guessing what the future will be, but okay, I will try to fill the futurologist's shoes. So I've read about new types of wind turbines, like a turbine the shape of bird wings or power generating kites. So I think that's the future, the visible one. So it will be interesting because we can see this evolution for ourselves. But I think there will be also another less visible future, which will be driven by AI, the artificial intelligence. So the application of machine learning will be wider than it is now. And I think that it won't be limited to predictive maintenance only. It would be useful for wind energy distribution or, for example, the effective wind utilization. So the area of the application will be much more wider than now. But as I said, I'm just guessing. However, I'm quite sure that in the future, the machine learning will play a very important role in wind energy industry.
Thank you, Tomek. That's such a detailed answer, so I'm really happy about it. So, okay, we can go to the next question. And so the question is, what are the characteristics of a good predictive maintenance solution for wind turbines? And maybe Pavel?
Yeah, okay. I will answer this one with pleasure. So we have done some research on the market, and we noticed that the majority of the solutions powered by machine learning, or even some simpler data analysis, have the form of a more or less sophisticated dashboard. And these kind of applications usually support only a tiny part of the whole business process, and require a technician or even data analyst to manually trigger some maintenance actions when they are needed. So we think that the predictive maintenance algorithm are not only solutions on their own, they are just tools which, if used properly, should support the business process and make some significant savings. And this doesn't only include a visualization of the current or predicted state. It also supports the process of for instance, of inspection, ordering parts, sending the crew, managing inventory, and so on. So it's more about solution, not just using the tools.
Okay, thank you. I have a next question. SCADA is the most common system for collecting wind turbine data. And what are the advantages and disadvantages of that system?
To answer this question, I saw the question from Jesus about the SCADA, so maybe it will be possible to answer both of those questions with this one answer. It is possible to build a machine learning algorithm for predictive maintenance based on the SCADA data only. And the advantages of the SCADA system is, first of all, it's relatively easily accessible. So there is no problem in comparison to other data systems. It's quite easy to access to this data. The second one is that the SCADA system has the cheapest sensors, and the data is collected in the form of time series. So it's quite easy to visualize and analyze this data. The main disadvantage of the SCADA data is that you can find better data sources which can give you a better failure lead time. So, but you have to invest in those sensors.
Okay. And what other wind turbine data could be collected? And is it really worth it?
Okay, so as I said before, you have to invest in those type of data. And for instance, you can invest in oil and grease data, and this type of data can be analyzed automatically, and it's easy to make visual inspection on it. And using this data for predictive maintenance can deliver better failure lead time, better in comparison to the lead time based on SCADA data, especially for bearings and gearboxes. The problem with oil and grease measurements is that those sensors are quite expensive. Another possible solution is the vibration analysis. And here we can distinguish two types of sensors, high and low frequency. The vibration data gives the best failure lead time for bearings and gearboxes, and the cost of vibration sensor is quite similar to the cost of oil and grease sensor. So it's quite effective investment in vibration sensor.
Okay, thank you for the answer, Tomek. And I have a next questions for you guys. So going more deep into the predictive algorithm. So maybe you can describe how does predictive algorithm work? Maybe Paweł?
Yeah, I could talk about it for hours, but I'll try to make it short. I will talk only about the predictive algorithms we were working on. And the family of the algorithms we use for this particular problem is called supervised learning. Internally, the algorithms from this family, they differ from each other a lot, but in general, the way of working is exactly the same. So they just take the historical data and try to find the pattern, which allows to predict a given value on a new, never-seen data set. And it's called supervised because we supervise the process of learning. So we know arbitrarily which observations are erroneous. So the algorithm can calculate what is the overall cost of returning certain set of values, and then it tries to just minimize that cost. And usually, the more data we obtain from the past, the better results we can get from the models. So then there are various techniques to clean up and process the data, normalize it, augment it with additional information. In our case, we were given with a SCADA data set containing measurements from various sensors of a wind turbine. And additionally, we obtained data from weather stations, which allowed us to improve the results. Then we just cleaned up and pre-processed the data by adding additional dimension, aggregating and removing the outliers. We also tested different approaches because, as in real world, we use what works the best. So we checked the recurrent neural networks with and without Weibull distribution, various tree-like models, and ended up with models trained per each component type, where some of them were simple decision trees, and others, for instance, were using an ensemble technique called boosting, which means we use several weak models, which in fact don't perform well, and then we connect them in a sequence, and as a result, we got a model which was much better in terms of performance. And in order to find the best moment to send the maintenance crew, we have optimized the hyperparameters of the model using custom cost function. The estimated cost of sending the inspection in given point of time. Okay, maybe I'll stop here because I could talk for hours on that, but back to you, Matt.
You definitely can. And Paweł, but is there any other solution algorithm for predicting failures?
Yes, of course. So the number of ideas how to predict failures with best accuracy is, we can say, endless. During the Hack the Wind hackathon, our competitors have used, for instance, a convolutional neural network, which is usually used for data sets containing images. And this, we can say, creative approach allowed them to outperform our models slightly, but still. In the future, we'll certainly verify this solution, if this solution can be somehow connected with ours to get even better results. And also there are various techniques and models for the time series data, which can be adapted depending on the exact problem we are solving. Not to mention improving the results by obtaining new important features which have impact on the target variable.
Okay, and Paweł, can you improve the results of the algorithm?
Yeah, we are more than sure that the results can be improved drastically. So don't forget that the results I was talking about just a while ago were coming from the model trained on the dataset of only 5 wind turbines for only 1 year. So believe that when we gather more data, the performance can be improved, especially in terms of the prediction time, how much in advance it is returned before an actual failure occurs. and reducing the number, the number of false positives. This was a big struggle for us. Yeah, and also we'll be testing different methods and approaches. Perhaps there is some model which would outperform the one we have created. Another way of improving the results is to find some new important features. Here, the first thing which comes to my mind is the data from vibration sensors, as Tomek mentioned before. This seems to be very efficient for training ML models, and it gives very good results. But on the other hand, the sensors are quite expensive, and not all the wind farms are equipped with them. Yeah, and there are many other ways of improving the results, but maybe let's stop here. We are time limited.
Okay, so now we know a lot about the algorithm and the backend, so maybe we can move on to the something more maybe related to the user perspective. So I have a question for Paweł, our designer. So the technical aspects of the machine learning solution is critical, but it's visible for the user. So how to make a machine learning algorithm results actionable for the user, in your opinion?
Okay, so like you said, the algorithm is fun to create and stuff like that, and if it works, it's great. But how a person like me, for example, or any other common people can actually benefit from it when they do not understand it, because it's very complicated. So let me quickly introduce you to our hackathon prototype of the application we managed to create during those 2-3 days in Hamburg. So like I mentioned on the beginning, one of our aims was to create a actual product for the users that they can use and benefit from, and we came up with a mobile app. That's of course some rough representation of our idea, but still it shows our approach to the problem and sort of our solution to it. And like you can see, there's a mobile app for that, a quick solution, accessible and mobile at the palm of your hand, that you can monitor your wind farm at any point, seeing basic data and stuff. And of course, when the algorithm predicts a failure, it can easily inform you about that. So thus you can see the alerts here and stuff like that. But actually that's something that some products that already exist on the market already do. So they can alert you about some malfunctions of the components. But what they can't do now is they don't allow you to take an action. So you have the knowledge, not early enough probably, but you have some knowledge about something has failed, but you cannot do anything with that. And our approach is that you actually can take an action that, so you can either schedule an inspection or create a maintenance task for your service guy and send him actually to this place. And not only it can be, 2 separate words, but you actually can have a deeper connection and combine those 2 users. So like feel and see, get the ticket, go there, help them to get there and to navigate them precisely to the exact issue. And even more, you can combine in that all the logistics regarding the warehousing spare components that normally takes time and knowledge to know that you need to acquire them before. With our solution, probably you could not only know earlier because of the algorithm, but also monitor the whole flow from the warehouse when the parts are stored until the actual part exchange, when there will be a predicted malfunction of the component. And react on that and save money simply because of simplified flow, and all that in a very reasonable manner, easy to read interface and not really complicated. You don't have to be data science expert to actually read this through. So in general, that was the idea of how the app could be represented in the hands of the final users.
Okay, thank you for sharing that and showing us the prototype. So for me, it looks really well, but what are the plans for the further development of this predictive maintenance software, Paweł?
Okay, so on behalf of our team, I can say that after the hackathon, we were pleased that our solution was quite kindly received from the market, because we had the opportunity to verify and validate a bit our idea there on the expo in Europe. Thus, we decided to move forward, do next steps. And as a team, we decided that we would like to create something more from that, an actual product. And we also want to do that in sort of a business manner, with the help of lean startup approach and stuff like that. So currently our next steps are validating our business hypothesis on actual market, infiltrating the market itself deeper, getting connections on the market itself, also developing the algorithm further to make it even more precise and accessible for more markets, maybe not only the wind turbines market, but maybe it can be applied to some different circumstances. Yeah, and moving on with the idea and finding maybe some partners and stuff like that.
Okay, thank you a lot. So guys, we are having the last question before we move to the Q&A session. So I think the timing is really good. So my last questions to you is, what are the possible ways to collaborate with Boldare machine learning team?
Okay, so yeah, as Paweł said, we are still in the phase of software development, so we are eagerly looking for a collaboration in different areas. We will be happy to fit the predictive maintenance model with more data, because it will give us the opportunity to improve this model. It will be also great to find some people with domain knowledge to cooperate. We have a few hypotheses about market expectation, which we want to verify with people from the industry. Moreover, with such help, it will be possible to use this domain knowledge to increase the quality of predictions, because, as we said, we have an experience in machine learning, but our contact with the wind energy sector is relatively short. We have more experience in image recognition, machine learning models for customer activity like churn, like marketing spending optimization, or recommendation systems. But we still are looking for additional knowledge in the area of wind energy industry.
Okay, thank you, Tomasz. Thank you, guys. Now we have, it's time for our Q&A sessions for the next 15 minutes. So thank you for posting all of the questions. Probably we won't have time to answer all of them, but we will try to answer, as many as possible, and we will go by the most upvoted. So I think the first question is from Carlos, and it's, do you think you can apply the same machine learning techniques to different platforms, and why?
Okay, so maybe I can answer. As we were talking before, we actually used the same machine learning techniques for other problems, and the problems you can solve with this, let's say, family of algorithms. So supervised learning is, we can say, endless. There are for this particular kind of problems, so time series data. Also, there are various implementations. So I can say that not exactly the same model we can use for all the possible problems, but the approach is usually similar. So we clean up, reprocess, we try to understand the data, find new important features, and so on. Then we utilize models, train them on historical data, and now it's like not. For the model, it's not important what data is inside. It's the important is the quality of the data, and then we can generate predictions for all the kind of problems. So answering shortly your question, yes, we can apply the same techniques.
Okay, thank you, Paweł, for answer. I have another question. It's coming from Mr. Calderon. And is your solution scalable enough? Can you do the same you did in 48 hours for larger fleets in a short time?
Okay, I can try to answer this question. Shortly, yes, we can. The solution is very scalable. We just have to feed it with enough amount of data, and then we can use it on the small, medium, or big farms, or even the whole families of wind farms. There's no problem with that. We just have to get the appropriate data to learn the model with the characteristics of those wind turbines, and then we can develop the adjusted model for each case. So it's scalable.
I'll just quickly add to this answer that the model we have created during the hackathon was already scalable. So we didn't train the model on our own laptops and computers. We were using Google Cloud infrastructure, which is very scalable, and we can use various processing power. So we used, if I'm correct, 16 cores CPU, but it's just a matter of a configuration to switch to, for instance, TPU if you use some neural networks. The another problem here is data storage. So we can imagine that the data coming from 5 wind turbines doesn't weigh too much, but the data from several years for a bigger farm will be bigger. But here we also have an experience with that. We use different data storages to store that kind of data. Also, we can try to aggregate the data, which we actually did during the hackathon. So we didn't use every 10 minutes period. We aggregate that to 1 day to generate the predictions, which just decreased the volume of data. So there are various techniques for dealing with higher scale, and we are aware of them. I think maybe not all, but majority of them.
Thank you, Tomek and Paweł. We can go to the next question from Carlos, and it's: why do you think the generator was a little more difficult to get it right?
Okay, I will try to answer this question because it's also a very interesting problem for us. We don't know. We have a few hypotheses. We want to verify it. We are still looking for some domain knowledge. One of our hypotheses is that in the generator, you don't have any moving parts. So you have only the data about the temperature, which is not quite useful for a generator. Probably a better solution will be to have a heat map of this component. And in addition, the temperature of a generator is strongly correlated with the temperature, the general temperature in the air. So it's quite hard task to solve, and we think that if it will be possible to get more data, it will be also possible to increase the quality of the prediction for generator. That's one possible solution. The second possible solution is to find some domain knowledge, some specialist with domain knowledge, which can help us to analyze the characteristic of the generator, and maybe to use this domain knowledge to improve the model.
Okay, thank you. Let's move on to the next question from Mr. Jesus Lapara. Is SCADA data refresh time each 10 minutes enough for implementing machine learning?
I can continue the answer on this question because I started to answer on it during the interview. It's enough because the refresh time 10 minutes after 10 minutes is sufficient. For example, if you have observation from the year, we started to analyze thousands of data from several or even a dozen of different features. So it's a quite sufficient amount of data for machine learning. Because we can deal with those data in different ways. We can use the data augmentation techniques to increase the amount of this data to prepare some additional features. So we can really make the usage from the SCADA data. But as I said before, if the data from oil or grease sensors or the vibration sensors are available, it's always worth to add those type of data to the SCADA data and use them together.
Okay, and we have another question from Mr. Jesus. Is, do we need extra sensors to apply machine learning?
So
I can answer this one, but you have already answered part of it.
I think I already answered this question. No, we don't. We can use just the SCADA data, and it's sufficient.
Okay, thank you. What's next? Okay, maybe we take the question from Krzysztof. Is that solution ready for any wind farm if you receive standardized data? What other data are important for this model, like type of turbines, etc.?
Okay, so maybe to give a short break for to Tomek, I will answer this question. So as we use the SCADA data, it's a kind of standard. So now we can use more or less the same models and technique to any wind farm which utilizes SCADA data. So in short, yes, it's ready for any wind farm which uses SCADA data. But if any wind farm uses some additional sensors, like vibration or oil and so on, we can also apply that kind of data to the standardized one. So yes, and also via transfer learning, for instance, if we use neural networks, we can use pre-trained networks. So basically, we can when we get more data and train a better model, we can then use a pre-trained part of that model and just append at the top of the model anything which is specific for particular scenario. So we can even transfer the knowledge we obtain from different farms to achieve better results in some other farms.
Thank you, Paweł. Okay, so we can question. So maybe this one, it's also from Mr. Carlos. So Mr. Carlos is very active today, so I'm very happy about it. So the question is, how do you evaluate the inputs for the machine learning models? Do you have operational experience with wind turbines?
I can try to answer this question. I think that you can find a general approach for predictive maintenance problem, which is independent on the industry. So you use more or less the same type of machine learning or data science techniques to get the insights. Generally, you want to find, I can name it some kind of causation or correlation sometimes between the failure and the features from the wind turbines which you want to use to predict these failures. So we evaluate the inputs for the ML models with not to be too technically speaking guy, typical techniques for the input evaluation for predictive maintenance model. And do you have operational experience with the wind turbines? I don't know if I understand correctly the operational experience, but if it is the experience with the wind turbines as a domain knowledge, then we don't have such a experience, such a knowledge. We are rather guys with the experience in machine learning, which we want to transfer into wind energy sector. And we want to predict the failures for wind turbines using our machine learning experience. And since September, we intensively tried to learn something about the technicalities of wind turbines to use this domain knowledge in our algorithm.
Okay, thank you for this one. I see a question from Karina Ospina, and it's, do you think you can apply same machine learning techniques for two different machines?
Okay, so I will just quickly answer. I believe this was already answered that was the first question, if I'm correct. So as I said before, yes, we actually use the same techniques for various problems. It's a matter of the problems are, we just categorize them and use similar techniques for each of them, which doesn't mean that we use the same models. It's a different thing, but regarding the techniques and the approach and the models we actually utilize, yeah, this is more or less the same for in different industries even.
Hello, and I think the last question for today's webinar is probably a follow-up question from Mr. Jesus. It's, should we use average values or raw ones?
So also we answered a bit of this question before, but I will continue on the topic. So it depends. It depends on what works better. We actually used aggregated varied values, so we didn't use the 10 minutes period. We aggregated that to 1 day period, and this was in order to avoid overfitting, and also to make the training faster, because as we said before, this was a hackathon, so the time was very important here, and we didn't have time to wait for the model to train overnight, for instance. Usually in production implementations, we actually can wait for a bit longer for the model to train. Not all the models are able to parallelize and to work on multiple instances and so on. So If we get more data, probably we would use a smaller period, and maybe we wouldn't aggregate at all, but we cannot tell for sure. We always test different techniques and different approaches, and we just use what works the best. That's why, for instance, we used totally different models for different components. So this was not like that there was one model for everything. Every component had its own model, and starting from some simple decision trees, we went through neural networks, even to some kind of ensemble techniques, so joining the models. Okay, I will stop here because we are.
Can I add just a few more sentences to that? We still have a time. Okay, we still have time. So a few more words about the raw data. It's always better to get raw data because we can calculate the average values from raw data. It's quite simple, but we cannot make it in different directions. So we cannot change the average values into raw data. And also the raw data is better because using raw data, we can prepare another type of aggregated functions, not only the averages. We can use, for example, just giving the simplest examples, the median, the standard deviation, the max-min values, and it delivers some type of the information about the range and the deviation in the wind turbine during the time of the monitoring. So it's quite useful to have the raw data and to have the possibility to modify this raw data in the way which is the most effective for us in terms of predictive maintenance quality.
Thank you, Tomasz and Paweł. And okay, we are getting to almost the 11 a.m. So we have just last 2 minutes. So I'm afraid that we won't have enough time to answer all of the questions. So if you have other burning questions, you can send them directly to us at email address, which is wind@boldare.com. We'll put it into a chat, and we will try to get back to you as soon as possible. And just to summarize what was said today during the webinar, here are 3 key takeaways for you. Is the cost and time of maintenance can be reduced significantly with predictive maintenance, but what's more, machine learning-based solution can elongate the lifespan of turbines and optimize energy production. So in just 48 hours of coding, we've managed to save 12,500 per turbine. Although data is limited, there are possibilities to improve the models by improving the models and by searching for new data sources such as vibration sensors. And predictive algorithms are just tools which should support other businesses' process, for example, in the form of an app that can help plan and carry out the process of inspection, ordering parts, sending a crew, managing inventory, and so on. So guys, thank you all for joining us during the webinar. We really appreciate your active participation, all the questions and comments you've posted during the webinar. Special thanks to our speakers who shared their insight with us. The video from the webinar will be posted on Boldare YouTube channel. The link will be included in the email summary. If you have any other further questions, please don't hesitate to email us at wind@boldare.com. We'll be really delighted to set up one-to-one calls with our machine learning team and respond to your specific needs. So don't forget to follow us on our LinkedIn profile, where we post all updates regarding forthcoming webinars and more. So we really hope to see you soon at the next webinar. So thank you all. Goodbye.